So let's move ahead to the next question. How can we do WCF concurrency and throttling? Now concurrency means happening at the same time. So you would like to handle, means you would like your WCF service to handle multiple requests at a given moment of time. Now by default, all the WCF services handle only one request at a given moment of time. So they are more like synchronous kind of thing. So we'll see in this session that how we can handle WCF concurrency and how we can basically use WCF throttling settings, to limit the number of requests, number of instances on a WCF application. Now there are two reasons why you would like to use WCF concurrency and throttling. The first reason is but obvious, that you would like to increase the throughput of your WCF service. Throughput means how much work a given thing can do at a given moment of time. So basically you would like to increase the amount of work your WCF service instance can do at a given moment of time. The second is integration with legacy systems. Now what happens many times is it's possible that your WCF service is interacting at the backend with some COM components or some legacy components which are not multi-threaded, but they are single-threaded by themselves. So what you would like is you would like to use WCF throttling and the combination of WCF concurrency to limit the number of requests which is sent to the single-threaded component or single-threaded application. So there are two reasons why you would like to use WCF concurrency and throttling. First is definitely you would like to increase the throughput, and second is you would like to integrate with legacy systems. So in other words, you would like to make your WCF service compatible with the legacy systems. Now before I move ahead, there are two important things: WCF concurrency and WCF instancing. WCF instancing we have already seen in our previous sections. Now both of these things are a bit different, okay, or they are very much different, I'll say rather. WCF instancing, as we have seen, is nothing but you would like to control how many object instances will be created. So you would like to control how many objects instance will exist to serve your request, while WCF concurrency means how many threads will make a call to a WCF service. So both of them are different. Said and done, even if they are different, when you actually try to give a solution of WCF concurrency, the WCF instancing plays a very important role into that. So when we try to see the samples, you'll understand that how WCF instancing also affects WCF concurrency. But I just wanted to make a point here that WCF concurrency and WCF instancing are different. Instancing means how many objects will be created of WCF service on the server, while threading means how many concurrent calls can be made to the WCF service. There are three different ways of configuring WCF concurrency. One is a single, which is by default. So in single concurrency, what happens is when you specify your concurrency type as single, only one request will be processed at a given moment of time. So in other words, if there are multiple requests, then the other request has to wait until the first request has been processed. In multiple concurrency, what happens is when you specify the concurrency type as multiple in WCF, multiple requests can be handled by the WCF service object. So in other words, multiple requests are processed at the same time. So it is like more of a multi-threaded environment. We have one more type of WCF concurrency which is called as reentrant. We'll talk about the reentrant later on because it's a bit complicated. I'll explain you with a figure and etc. Now what we'll do is we'll create a simple sample project and we'll try to see that how the single concurrency is configured and multiple concurrency is configured, and we'll try to see that what is the effect of configuring a WCF service by single concurrency and multiple concurrency. So here's a simple WCF service we have created called as the Hello World service, and this Hello World service basically implements the interface iHelloWorld service. Now if you look at the iHelloWorld service, it has basically a call method which takes in a client name. Now what we are doing in this call method is we are incrementing an instance variable. So I've declared a class level instance variable called as public int I, and I'm incrementing the class level instance variable with every call method with every call made to the call method. And what I'm also doing is that I'm just throwing to the console the client name who is calling, the thread ID of the WCF client who's calling, and finally also the date and time when the call was made. And then I'm halting for 5 seconds. So after we make a call to this method of the WCF service, it will basically pause for 5 seconds. Now at the client side, the client which is consuming this WCF service, what I'm doing over there is I'm basically making some rapid calls. So you can see that this is where I'm basically calling the client, calling this WCF service. So basically I'm making a call to the WCF service, rapidly for 5 times. And this WCF service is self-hosted. So you can see that this is my self-hosting code. We have already covered the WCF self-hosting in one of our previous tutorials. So basically, what do we have here is basically we have here is the WCF service, right? You can see the class library of WCF service, and this WCF service is hosted in a self-hosted manner on the console WCF service or WCF server. That's a project for hosting, and then we have the client who is consuming the WCF service. So how do we specify concurrency now? By default, all your WCF services are single. So in other words, they are synchronous. In order to specify the concurrency mode, what you can do is you can go to the service behavior tag of your WCF service, and you can specify the concurrency mode, and there you can specify the concurrency mode as multiple, as single, re-entrant, etc. So basically at this moment I have specified it as multiple. So let's go and build this. Now what we'll do is expected. Let me just see what. Oh, it's a bracket there. Now what we'll do first is we'll basically configure the WCF service as single. So in other words, we'll not specify any concurrency mode. As I said that by default, all your WCF services are single, concurrency mode is single. So let me just build the solution, and let's go and run this. So that's my WCF server which is running, and it is ready to listen to client calls. Now what I'll do is let's go and run the client. So let me go and run the client. So basically here's a WCF service which is running now, and here's a client. So let me give a client here called as client 1. Now because it is what you call single, the WCF concurrency mode is set to single, you can see that it is waiting for 5 seconds. Even though I have made rapid calls at my client side, the server is processing the request after 5 seconds. So it is only taking one request at a time and then giving the output. And the other important point to note here is the instance value. If you remember, we had also created a member level instance or a class level instance called as int I, and because our instance mode of a WCF service was set to per call, every time you make up a call, a new instance of WCF service was created. So you can see that the same thread is used, the thread ID is same at the server side. The time is 5 seconds of delay. Why? Because WCF service is taking every request in a synchronous way, because this is by default the concurrency mode is set to single, and because the instance mode is single, instance mode is per call, it's creating new WCF objects over here, and that's why the variable is always set to 1. So basically you can see that because of the single call, or the single concurrency, what has happened is there is a 5 seconds of delay, even though you have made rapid calls from a client side. So if you remember the client code, it is making rapid call, it is not waiting for 5 seconds. But because the server is configured as single, it is taking the request one by one, rather than taking in a multi-threaded manner. Now what we'll do is let's go and configure the WCF server as multi-threaded or as multiple. So what we'll do is we'll go to the service behavior tag of your WCF service, right? And let's configure the concurrency mode as multiple. So now we are running the concurrency mode as multiple. So let me go and run the client. The server is already running. So that's my server that is running, and this is my client. So let's specify a nice client name here, client 1. Now what should happen is basically the server should not wait for 5 seconds. It should just take up the request, keep doing the request at the back end, and then take up the other request from the client. So we should not see the 5-second delay. So now you can see, as compared to the previous scenario, where we had configured the WCF service as single, here now you can see multiple. So you can see that the time, the server time which is displayed, there is no 5 seconds delay. There is a 1 second delay, but that is just probably to take up the request or create objects. So that's that's not really a big deal as such. So, and you can also, one of the important point to note here is the thread ID. You can see that there are different threads used now to serve the request as compared to the previous instance, a previous concurrency mode single, where the same thread ID was displayed. So you can see that the 5-second delay has gone off, and this is basically your concurrency mode as multiple. Now we can come up with 9 combinations of instancing and concurrency. So you can see that basically by using the instancing mode as single, per session, per call, we can use the concurrency mode of single, multiple, and reentrant and create 9 combinations of instancing and concurrency. In our previous examples, what we had done is we had specified the concurrency mode as per call, and we had specified the instancing mode as per call, and we have specified the concurrency mode as single and multiple. So you can, if you remember, the instance variable I was only set to 1 every time. Why? Because for every call a new WCF server object was created to serve the request. So depending on a situation, you can take one of the combination which suits as per your project. So for example, let's say that if you are looking for a multi-threaded environment, with a single object created on the WCF service side, then probably you can look into single, with multiple combination. So this one, multiple threads for all clients. So depending on a situation, you can use one of the combinations of the instancing and the concurrency mode. If you want to test, how those 9 combinations will work, what you can do is you can go and start changing the instance context mode, and as well as the concurrency mode. I can see that with every combination how the things look like. Now what I've done is basically over here I have specified the per session. I've changed first it was per call, I've just changed it to per session, and I've kept the concurrency mode as multiple, and I've ran this project. Now let me go and run my client, and let's see the difference. If you remember, in our previous runs, the WCF server was configured as per call. So that's why the instance variable was only 1, 1, and 1. But at this moment, you can see that the instance variable is 1, 2, 3, 4, 5, and the concurrency mode, because it is multiple, there is no delay between every call. So what you can do is basically you can start, experimenting around this instance context mode and concurrency mode, and you can have a better idea of how WCF concurrency works hand to hand with WCF instancing. Now we have one more concurrency mode which is left out, and that is reentrant. So let's try to understand, basically what basically is WCF reentrant concurrency mode. When the WCF concurrency mode is set as reentrant, only one thread can run at a given moment of time. Now said and done that, when that thread is running, when a single thread is running for a given moment of time, and if that thread makes an outbound call to some other WCF service or makes a client callback, then the thread is released, and any other thread can come in and basically call the WCF service. So for example, over here you can see that there's a client instance 1, and he makes up a call. Okay, now this is single threaded, so no other WCF client request will be taken in, and let's say that this thread basically makes up a call to the external WCF service. Now at this moment the thread is released, okay, and any other client can call up this WCF service and service request. So in other words, reentrant is it's like a single mode. In other words, it's only single threaded, but it releases the thread in case that thread is making up a call to the external world, or it's making up it's making an outbound call to some other WCF service. Now with WCF concurrency, one of the other important fundamental is the WCF throttling. Now WCF throttling setting helps you to put an upper limit on the number of concurrent calls, on the number of WCF instances and the concurrent sessions. So you can see that it provides 3 properties here. The first one is the max concurrent calls. Now the max concurrent calls basically limits the number of concurrent requests that can be processed by the WCF service instances. Then the next thing what we have is the max concurrent instances. Now this limits the number of service instances that can be allocated at a given moment of time. So if you remember the per call, per session, but even though you can which helps you to provide that how you want to control your WCF instances, but in case you want to put a cap on the number of instances, you can use the max concurrent instances. Now remember, one of the points for max concurrent instances is that when it is per call, then definitely this value is of no importance as such, because the number of calls will be equal to the number of instances. For per session, this value equals to the number of active session instances. Okay, and this session, this setting doesn't impact for single instancing mode, because over there only one instance of the object will be created. The last one is the max concurrent session. This limits the number of active sessions allowed for the service. Now there are some default values for the WCF throttling. So basically, if you are using 3.0, then there are some different set of default values, and if you are using WCF 4.0, then there are some other values for that. So you can see for 3.0, the value for maximum concurrent calls is 6, instances 26, and concurrent sessions it is 10. Now what they've done for 4.0 is the value doesn't depend, it's not just a single or absolute value, but it depends on your processor. So you can see the maximum concurrent calls is 16, but into the processor count. So if it's a dual processor you have, then it will be 32. And the maximum concurrent instances will be the total of maximum concurrent calls plus sessions. And the maximum concurrent sessions you can have is 100 into processor count. So the processor, the number of processors what you have on your PC will decide that how much concurrency your WCF service can handle. And that looks logical. Why? Because remember that concurrency is all about threading. It's basically it spawns threads, and threads at the end of the day is nothing but basically where you want to execute two things in parallel, or you want to execute logics in parallel. And to achieve parallelism, one of the important criteria is number of processors what your PC is supporting. So the WCF 4.0 is a very logical thought process, where the default values depends on the processor count, rather than just the absolute values. I hope that this session was useful, and in the coming of sessions we'll look into WCF REST, and we'll see that how WCF REST is different from our normal WCF SOAP messages.